Good afternoon. Today we are continuing to work with those equations, and we are doing PO16. I can solve equations using addition and subtraction. So even though there is so much more to algebra than solving for a variable, it's what most people think algebra is all about. It's actually one of my favorite parts of the algebra. It really shouldn't be painful. Here are 3 ways you might think about how to solve a basic equation. Then we're going to decide which method works best for you. So we're going to learn all 3 ways. We're going to take notes on all 3 ways, and we're going to practice using all 3 ways. And then you're going to choose the one that works for you. Because we know with math, there's lots of different ways to do something to get the same answer. So we're going to find which way works for you. So I do not want us working ahead. I see some of us are frantically trying to work ahead. Please be following along with me on the correct page with me, taking the notes with me. So the first way, we're going to look at our problem, n plus 6 equals 18. First thing, we're going to use logic. What is the expression as a question? So if we were to put n plus 6 equals 18 as a question, we would put what number plus 6 is 18? So that's using the logic. What number plus 6 would equal 18? Then we have opposite operations. The opposite of adding 6 is subtracting 6. So we're going to subtract 6 from both sides of the equal sign because we need to balance it out. And that will get the variable by itself. So what that looks like is we have n plus 6 equals 18. We're going to, because we added 6, we're going to subtract 6 from both sides. So 6 minus 6 is 0. So I don't have to say n plus 0 because n, or 0 plus anything is going to be that number. So it just becomes n equals, and then 18 minus 6 is 12. Then we can use fact families. So remember those fact families with our adding and subtracting. So if we have n plus 6 equals 18, we could say 6 plus n equals 18. We could say 18 minus n equals 6, or 18 minus 6 equals n. Which one of those fact families is going to help us the most, Matthew?
The fourth one.
Yeah, that last one. 18 minus 6 equals n. That one's going to really help us know what n equals. So if we have 18 minus 6 equals n up here, we have 18 minus 6, we know it's going to equal n, which is that 12. So as with any equation, once you find a value for the variable, you need to check your work. And to do that, you need to put that variable value back into the equation. So we want to see if it works. So here we found n equals 12. So we're going to put that back into our equation and say 12 plus 6 equals 18. 12 plus 6, who knows 18? 18 does equal 18. It balances out. So yes, I know that is truly my answer. So n equals 12 because I can balance it. Does that make sense? So whenever we do finding a value, your final step is to put it back in the equation and say, does it work? Does that solution work? So let's look at how we're going to use that on the bottom of this page. We're going to use 2 methods from above each time, solve for the variable in the equation. So we learned 3 methods: logic, opposite operations, and fact families. So let's look at how we would do that. We have 8 plus n equals 25. We're gonna see how it works for all three of them. What would be my logic question? How would I write that as a question, Madden?
8 plus what number equals 25?
8 plus what number is 25? How would I do it with the opposite operations? So if I have 8 plus n equals 25, how would I use opposite operations for that?
Would you subtract 8 out of 8 and 8 out of 25?
Yeah, because this 8, it's a positive 8. Positive is a plus. The opposite of plus is subtract. So if we want to do our opposite to get n by itself. So if this is adding 8 plus 8, positive 8, we want to subtract 8 from both sides. 8 minus 8 gives me that 0, so I have n by itself. 25 minus 8 is 17. How would I use fact families to solve this? Addie?
You would put like 8 plus n, or n plus 8, or 25 plus n, or 8, 25 minus 8.
There you go. 25 minus 8 equals n, and what would my other one be?
25 minus n.
Equals 8. So this one is the one that's like what we had up here. 25 minus 8. We're going to get that 17 for an answer. So your final answer, you're going to want to solve it. Am I done? Why not, Kaylin? I need to check my answer. So I need to go back and say, okay, 8 plus 17 equals 25. 8 plus 17, 8 plus 7 is 15. Carry the 1. So 25 does equal 25. So yes, this is a true statement. This is my very final answer. Because I went back and I put it into my equation and it worked. So let's look at our next one. This bug is really bothering me. Oy. Yeah, I'm just trying to brush the bug away. Okay, so n minus 13 equals 19. What is my question I would ask? Will.
What number minus 13 equals 19?
What number minus 13 is 19? How would I use opposite operations for this? So I have n minus 13 equals 19. Grace?
19 plus 13.
I have to do it to the other side. So I had minus 13, so I have to add 13 to both sides. Minus 13 is a negative 13. Negative 13 plus a positive 13 is 0. So I'm zeroing it out, so I have just n left. 19 plus 13 is 32. So how would I do fact families? I know I have n minus 13 equals 19. What would be the rest of my fact family? Addie?
18, like, why did I put 8? 13 minus n equals 19.
Can we do that? Can we flip our subtraction that way? We have n minus 13. We can't flip it that way. Do you see how that, so if it was 5 minus 3, we couldn't say 3 minus 5.
Yeah.
So what would my other subtraction one be? What do you think, Kyle? Or can you give me some addition ones?
Would it be 19 plus 13 equals 32?
Equals n.
Equals
What would be my other addition? 13 plus 19. So what is that other subtraction that I'm missing? Emerson?
19 minus 10 equals 13.
Not going to be, say,
N minus 19.
yes, that one works. N minus, oops, not equals, N minus 19 will equal 13. So either one of these are going to get us our answer. So let's see if that n does equal 13. So that is what I'm saying is n equals 13, sorry, 32. Whew. I am not done yet. I'm going to go back up and I'm going to put it in. If I have 32 minus 13 equals 19, I know this side will say equal 19. I need to borrow. So 12 minus 3 is 9, 2 minus 1 is 1. Look at that, 19 does equal 19. So I know my answer is truly n equals 32. For this last one, I want you to do all 3 methods. And then,
What if you did all 3 for the first 2?
what?
What if you did all 3 for the first 2?
Yeah. And we did that together.
Yeah.
So now you're doing it on your own for that last one.
Darn.
And then on the second page, you get to pick only one method you have to use. You don't have to use the same method every time. You can switch it up if you want to. If you look at one and say, oh, logic rules out, I know this one. Or you can say, I really have no idea what to do with this. I'm going to do my fact families. Or you can do the opposite operations. But you're going to show your work. Look at this. Show your work. And show that you checked your answer. So you are not just giving me an answer. You're not just saying, well, I can look at this and I know 13 plus 7 equals 20, so bam, n equals 13, done. You didn't show any work, and you're not showing that you checked it. So you have to show that work. You can say, what number plus 7 is 20? I know that is 13. I just knew that from mental math. But now I have to go back. I showed my work. I'm using logic. Now I have to go back and check it and say 13 plus 7 equals 20. 13 plus 7 is 20 equals 20. This is showing that I checked my work. So you must do both things. You must show your work to get your answer and show that you are checking it. This is checking your answer. Putting it into the equation and equaling out, balancing both sides of the equation. 20 does truly equal 20. We have a little bit of work time before our presentation. This is a silent work time. If you are watching at home, we hope you are well. We hope to see you soon. Have a wonderful day.